Hello, in this video, I'm going to go over the MA162 Exam 2 for Spring 2022. For number 1, we have an integral with a real power in the bottom. So from just the power, right, it's the power of 3 over 2. What I'm thinking here is that I can split that power into a square root. So we have like 1 over the square root of whatever's under, and then that will be just cubed afterwards, right? It will be to the third power and then square rooted. From here, we can see that the square root, right, it's in the denominator. That usually means trig sub is the best way. So therefore, I'm going to set up a triangle. Say theta is there. Then I want to have x here and 3 here, right? The perfect squares. And then here will just be square root of 9 plus square root of x. Square x. So in this configuration, I can then have tangent theta be x over 3, right? And then it would just be 3 tangent theta is x, and then take the derivative, then I have 3 secant square theta is dx. That there's a d theta there. And to relate the square root, I would want to use secant, since I want to relate them as simply as possible, right? I want to relate the constant term to the uh, square root term. In that way, I want to have the 3 in the bottom of the fraction, so it would be simpler to deal with, right? That in that case, secant would just be hypotenuse over the over adjacent, right? So I guess secant theta is the hypotenuse square root of 9 plus x squared over 3. Right, so the square root part, if I multiply the 3 over, is 3 secant theta. So now I can plug stuff in using this to plug for dx and this plug for the square root. Alright, so, and then the integral would be 3 secant theta cubed times 3 secant theta squared d theta. Right, and then we will have 27 secant cubed theta times 3 secant squared theta. Right, 2 of those cancel out. That will be a 9 in the bottom. So at the end, we have 1 over 9 secant theta. Right, but really think about if secant is just 1 over cosine, or cosine secant equal to 1 over cosine, so you can plug that in, and this just becomes 1 over 9. The constant doesn't change, but then it just be cosine theta. And that is a very simple uh, integral, right? That just goes to 1 over 9 sine theta, right? There'll be a plus c, but we do have limits of integration. In this case, I usually want to convert theta back to x, but in this case, if I convert the sine theta, it will be pretty complicated. It will be like x over like a square root. So in that case, I will convert the limits of integration to theta, right? So we have, we can use the tangent up here, right? Tangent theta. At what angle would I have like 0, and what angle would I have 1? Right? At 0, it's just 0, right? If you think about the tangent graph, it does something like this. So at 0, it's just 0. But the other one should be pretty well known too. Tangent of what is 1, and that should be pretty obvious for uh, the 45-45 triangle. It's 1, 1, root 2, right? And that would be just uh, 1 over 1. So so with the limit of integration would be secant equals 0 and secant, theta equal to 0 and theta equal to 45, which is pi over 4. So in that case, we can put that in. So we have 1/9 of sine pi over 4, and then minus 0, since sine 0 is 0. And then we can go back to this triangle up here, and sine pi over 4 is root 2 over 2. So then it would just be root 2 over 18, which is option E. For number 2, we have a difference of squares inside a square root. So generally we want to use trig sub for this, and we can confirm that by seeing all the answers are in fact, sine and cosine, meaning that they probably resulted from some form of trig sub, right? So first of all, we can draw a triangle for the trig sub, and since it's a difference of square, right, we can have 3 here. 3 squared is 9, and then x, the result, the last side will be just the square root of 9 minus x squared, and then we can say this angle is theta. And then we have x over 3 will be sine theta, whereas the square root over 3 would just be cosine theta. Right. From the sine theta, we can get the dx. If we take the derivative of both sides, 1/3 dx would be cosine theta d theta, right? And thus we can just put the 3 over. That's what we can sub for dx, and we can sub the square root of 9 minus x squared for 3 cosine theta. So here we can just sub these two back in with theta, then it would be 3 cosine theta times 3 cosine theta d theta, which will result in answer choice C, 9 cosine squared theta d theta. Number 3, we have a partial fraction decomposition, and for this, let's first factor the denominator here into different parts. So we can factor x out. It would be x times 1 plus x squared, right? And then our partial fractions would be, let's say, a over x plus bx plus c over 1 plus x squared, right? This is a non-factorable higher power. So here, this will equal to 1 over x plus x to the third. We'll multiply by x plus x cubed on both sides. Let's just say multiply the whole equation by this. So it will be a times the other part, 1 plus x squared plus bx plus c times x. This will be 1 over here. Right? It will be a plus a squared, ax squared plus bx squared plus cx equal to 1. and then I separate the different powers, right? For the x squares, there's no x squared on this side, so I have ax squared plus bx squared equal to 0x squared, right? I can take the x squares out, so b equal to negative a, or a equal to negative b. And then cx equal to 0x, right? So c equal to 0. And then I'll have a equal to 1, therefore plug into here, b equal to negative 1. So we can plug a and b back to here. So we will have 1 of x plus negative x over 1 plus x squared, which is the same thing as c. For number 4, we just have an integral, a definite integral with a square root and something under it. And in this case, right, generally, since we can't use up this, and there's no like simple power rule, since there's something in the square root that's complicated. So my first thought was thinking about trig sub, since that's one of the most efficient way to do these square root problems. But here is not clear, right? Might be a perfect square, or a difference of squares or stuff like that, but it's not clear. Especially since we have the minus x squared, right? Usually, if it's like 4 minus x squared, then that's pretty nice. But there's also x term. That means we kind of need to factor that in with something like a minus x squared or a plus x squared situation. In that case, right, that would be like a squared plus 2ax, or rather minus plus x squared, right? So that's what I meant by the minus here is a little problematic, since it should be a plus in front of that square term. But if we think of it as a different way, right? If I take the negative of this, right? If I have a just look at the x squared, and then I will take the inverse of that, this term. So it'd be minus 2x, right? And then to complete this square, I just need a plus 1, right? And this would be like x minus 1 squared. So that can be something I can do. And I can just put the negative in front, right? I can put a negative in front, then this will work out. And then it will be a 4 here. Since I need to make a 1, that would be minus 1, and then I would just put a plus 1 in front, right? It would be something like 3 is the original number, and then I will do, since it's minus 1 in this parenthesis, I'll do plus 1. So we don't just randomly add a number here. So then we have 4 minus x squared minus 2x plus 1, that's not a parentheses, right? And you can distribute this out, and this would be just be the uh, original equation. So this will be 4 minus x minus 1 squared. Now we have a difference of squares within under a square root. Then we can draw a triangle, right? And then we have 2 here and x minus 1 here. And then this bit would just be 4 minus x minus 1 squared under the square root. So now I'll relate, let's see, this angle's theta. Then sine theta would be x minus 1 over 2. And then cosine theta would be square root part over 2. And then we can take the derivative of both sides on here with the sine x, then it's cosine or sine theta, cosine theta d theta would be 1/2 dx, right? If I multiply in fact, for both of these equations, if I multiply these by 2, then I have, for the top one, 2 cosine theta d theta equal to dx. That I can just plug in for dx in the original equation, and then I have 2 cosine theta equal to the square root bit. Right. Now, I can just plug all that in. Do it over to the left side. I'm not worried about limits integration now. For now, I will plug in the square root, which is 2 cosine x, 2 cosine theta, and then dx is 2 cosine theta d theta. So now this is just 4 cosine squared theta d theta. Here we can use the double angle formula or the half angle formula, where let's just write over here, cosine squared theta equal to 1 plus cosine 2 theta over 2. So 4 times 1 plus cosine 2 theta over 2 d theta. From here, we can move the 2 outside. It would just be 1 plus cosine 2 theta d theta. And then just integrate that. We have 2 theta plus, it would be sine 2 theta. Because of chain rule, this 2 outside cancels out with a half that comes from the chain rule of 2 theta. And now we can look at the limit of integration. By plugging 0 and 1 up here, to the conversion we have to convert that into theta. So for x equal to 0, we have sine theta equal to 0 minus 1 over 2. So negative 1/2, I'm thinking about just the 30, 60, 90 triangle, where this is 1/2, but now it's negative, so it's just the negative range of just negative pi over 6, negative 30 degrees. Think about the unit circle. So this would be negative pi over 6, whereas for x equal to 1, sine theta equal to 0 over 2, which in that case just be 0. Now, can plug that back in. So we have 0 plus sine 0 is still 0 minus 2 times negative pi over 6 plus sine 2 times negative pi over 6. So this would be a negative negative, would just be pi over 3, and then it would be minus sine negative pi over 3, which again you can look at this triangle. It just be the negative of that, since that would be the sine 60 degrees would be pi, or root 3 over 2. Then this would be negative root 3 over 2. So we have pi over 3 plus root 3 over 2, which is answer choice E. For question number 5, we'll again have a square root, but this time we have a secant square in here. So generally, secant square and minus 1, formula you should pop in your brain is the identity, where it's secant squared minus 1 is tangent squared, right? And this comes from the sine squared plus cosine squared of any angle equal to 1, right? If you just divide both sides by cosine squared, then you have tangent squared plus 1 equal to secant squared. And then you can see what that comes from. But here, we can just plug that in, right? The tangent squared could just go in. I have just the square root of tangent squared theta d theta, which is tangent theta d theta, right? And how how we solve for tangent theta is we split that into sine theta and cosine theta and use u sub. I can use u equal to cosine theta. Therefore, du would be negative sine theta d theta. And now we can plug that in. We have negative 1 over u d theta, or rather du. Right, and then solving that will give us negative ln cosine theta. Right, just like negative ln u, and then we have that is over from 0 to pi over 3. Just plug that in. Negative ln pi over 3 cosine pi over 3 is 1/2. 1/2, and then minus ln 1 or ln 0. Wait, ln 1. Plug, it'll be cosine 0 is 1 and ln 1 is 0. So this whole part is just 0, right? But we don't see negative ln 1/2 in the answer choices, so we can do something here. We have negative ln. We can say this 1/2 is actually 2 to the negative 1 power, and then we can take that negative 1 outside, right? And then this would just equal to ln 2. Just some logarithmic rules, right? And then answer choice C is correct. 6, we have the integral, and from the first sight, we can kind of see that this is just 2 parts, right? So we can use by parts for this. And let's see, right? U, du, and then v and dv. So for u, we want to use L'Atier, so that would be the algorithmic of 3x minus 1 would be u here, whereas the e, the exponential, would just be dv. So now we take the, let me just fix that. Take the derivative, that would just be 3 dx. And then v will just be the integral of this, which is, just remember the chain rule, 2e to the x over 2. So now we can do uv minus v du. So this thing will equal to uv minus v du, v du. So now we have, I'm just gonna leave this be for now. And then that's just 6, and then that will be 12e to the x over 2. And all of this is over 0 and 2. So plug in 2, we have 6 minus 1 is 5 times 2 of e to the x over 2. That would just be 2 actually. So that would just be e here. And then this would be 12e. Minus, plug in 0, that will be negative 1, negative 2 e to the 0. Minus 12 e to the 0, which is just 1, right? And then we have, that will be 10e minus 12e plus 2 plus 12. So it'll be 14 minus 2e, which is option E here. 7, we have a integral of a fraction, but we can clearly tell this has a couple parts to it in the denominator. So we can use partial fraction for this, and it's nice enough that it already gives us the partial fractions that we need. Right, so for here, this is just a pretty simple partial fraction, right? X plus 1 plus b over x plus 3, right? And then this just equals to the original, right? And I can multiply the denominator to both of these, both sides, and then I will have a times x plus 3 plus b times x plus 1 equal to x plus 2. Right, so just distributing bx plus b will equal to x plus 2, right? And then I take the x powers together and then the constants together, right? And then I'll have ax plus bx equal to x, and then 3a plus b equal to 2, right? For the first equation here, I can divide both sides by x, then I have a plus b equal to 1, right? And then just solving the system equations here, I can just do, let's say this is equation 3, equation 2, this is equation 1. I can do equation 2 minus equation 3, then 2a equal to 1, right? And then a will equal to a half, and I can plug this back in to equation 3, then b is also a half. So here I can plug a and b back into this partial fraction we had earlier. Right, 1/2 over x plus 1 plus 1/2 over x plus 3. Actually, so this is the integral we want, right? And then that should just be, I can pull 1/2 out for these, right? And then it would just be ln x plus 1 plus natural log of x plus 3. All of this evaluated over 0 and 1. I can plug 0 and 1 in, so I'm gonna leave the 1/2 stay outside. ln 2 plus ln 4 minus ln 1 minus ln 3. Right, ln 1 is just 0, and then natural log rules, just logarithmic rules. Adding is, you can combine them with multiplication inside, and then dividing would just be subtracting would be dividing, right? So we have 1/2 ln 8 over 3, which is option A. For number 8, we have what it seems like to be just a pretty simple power rule, just an integral. But if you draw the graph of this 1 over x to the 4th, you realize that it looks something like this, right? And then here will be -1 and 1. And here, the part in the middle, you realize that as x approaches 0, this 1 over x to the 4th approaches infinity, right? If you have a limit, taking limit of that to 0, I just 1 divided by 0, which is infinity. So that's undefined. So we need to use improper to solve this, right? And then we can kind of see that this is a symmetric, right? The right side from 0 is the same as the left side from 0. So I can split this into 2, right? This would just be 2, let's say from 0 to 1. And now I'm going to take the limit of a arbitrary value, let's say b, to 0. This will be b to 1. Now I can take the integral. And that will just be -1/3 x cubed. Right, remember the chain rule. This would be from b to 1. Oh, I need to have 2 in front. So here, just plug it in. -1/3 1/1 minus 1/b. Right, and then you take the limit, you realize that here is infinity. Right, 1/0 would be infinity as you approach. Actually, I have to, let's say this is from the positive side. As you approach 0, right, this value would be infinity. So therefore, this whole part is just infinity, right? It's just 1 minus infinity is -infinity, and then times a -1/3, which doesn't matter, it's just infinity. So you have 2 times infinity, which is just divergent. For number 9, we have a pretty classic trig integral question. See here, with sine and cosine, and sine has the odd power. So in this case, I want to convert most of the sines into cosines, and just leave one sign for that u sub that I'm going to do later. So here, I will convert a sine squared, leaving just a sign behind, to 1 minus cosine squared. Right, in this case, after I distribute, then I will have two parts, right? I will have a sine x cosine to the 4th x with this one, and then I will have a sine x cosine to the 6th x dx. And from the side, we can write the u sub. If I let u equal to cosine x, du then is sine x negative sine x dx. Right, and then we can just u sub for this, and then the sine x part will disappear with the dx. Alright, then we have not worry about the limit integration for now. Just u to the 4th, rather negative u to the 4th, plus that would be u to the 6th. Right, and that's du. And now, we can just solve this integral, and that would be -1/5 u to the 5th plus 1/6, or rather 1/7 u to the 7, and all of this will be over something. But let's do that after we plug in for u. So here be -1/5 cosine to the 5th plus 1/7 cosine to the 7th, and that will be 0 and √2. Now we can plug these in, right? Cosine of pi over 2 is 0. So right, it's 0, and then same thing here, plus 0, and then minus, we'll have cosine of 0 is, cosine of 0 is 1, so we have -1/5 times 1, and then plus 1/7 times 1. Right, same thing here, cosine 0 is 1, so in this case we have negative, that would be -2/35, so we have 2/35. Which should be answer choice C. For number 10, we need to find the third term of a sequence that will produce the number -3. And then we're given a bunch of recurrence relations. And actually, if you did a lot of these exams, you realize this is actually the same question on the, I think, fall 2021, except they had an option F. But nonetheless, this is pretty simple. There's a simple way to doing this is just to write the sequences out, right? For option A, we have the first term is 1, right? The second term would be 1 minus the first term, right? The last term. So A2, the second term would be 1 minus 2 times 1, which would be -1. And then A3 would be 1 minus 2 times -1, which would be 1. And this one just oscillates between 1 and -1. It's not what we're looking for. For option B, we have the first term starting on 1 again, and this one. So the A2 would be just the negative of the last term, right? -1, and then just go back to 1. So that one, same as the first, same as option A. C, we have the sequence starting from -5. Then for A2, we have -5 plus 1, the last term plus 1 would be -4, and then -3. So this one will generate the A3 that we're looking for, so it will be the answer. You can do the other two, and it's not going to be A3, right? This one will be, for E, for example, it would be -1, -3, -9, right? And then for D, it would be 0, -3, -6, right? And those will not, although those do have -3, but it's in the wrong term, right? It's A2 has -3. So that's it's not going to be the answer we're looking for. For number 11, we have a limit that we're looking to evaluate. And up on a closer look, you realize that this limit here, since it goes to infinity, the top bar goes to infinity, right? Ln, when it approaches infinity, the ln, the natural log will approach infinity too, and then it's just infinity under, right? In this case, we have a infinity over infinity case. Then we could use L'Hopital's rule. So L'Hopital's rule, we can find the limit by taking the derivative of the top and bottom. If it's infinity over infinity or 0 over 0. So in this case, we can take the that should be dn derivative of the top part and the derivative of the bottom part. Right, the top part would be 4 over 4m plus 5, and then the bottom part would be 1, right? Since remember the chain rule, and in this case, right, this limit would just be 4 over 4m plus 5, and now we again can try to figure out this limit by plugging infinity in for n, right? In this case, right, top is just a 4, is a constant, over a infinity in the bottom, basically like this, or 1 over rather, because the 4's can cancel out, and that will just be 0, right? It's 1 over infinity will approach 0, so that will be option C. For number 12, we have a physical application of integrals. We have a water tank, and we want to empty that water tank, right? In this case, I want to draw the cylindrical water tank, something like this, where the radius, let's say the radius is 2 meters and the height is 8, but the tank is half full or half empty. So that would be 4 meters here if I say the bottom is at 0, right? And then I can say this is the height, right? This, I can say this is y or h or anything. But we're to find the work, right? Work done is uh, the integral of force by the distance, right? dr dh in this case. The force in this case would be the gravitational force opposing our work, opposing our pump, pointing downwards. So the force of gravity is mg, m being the mass and g being the gravitational constant. And then the mass we have, since we have a volume, we have like the dimensions, we can get volume, and then we can multiply that by the density to get the mass, right? So it'd just be rho vg will be our force of gravity for the work. But in this case, since every level of this cylindrical water tank will do different amount of distance, right? We want to separate this by disks, right? Every every small level, right? Create like really minute levels, and how each one has different work to be done. Right, so in that case, the volume we want would just be the singular layer of volume that we have, and that would be that volume would be pi r squared, which is just the circle, right? The area of the circle times the height of that circle, right? That would just be dh. We want to use integral and divide this into really small layers, so that dh will suffice here. And then we gotta remember the distance to be multiplied here, right? There should be like a distance here. That distance will be, let's say h. H will be the distance that it has to travel, right? Each layer, wherever h it is at, it will have to travel to the top, which is 8, right? So then the distance travel is just 8 minus h. Right, now we have all the things figured out. We can plug in back to the original. Right, we have f times h dh. Right, now since our water levels are from 0 to 4, that would be our integration limits. And then the force we have is rho g v, which is pi r squared times dh, and then we got to times the h. H would be 8 minus h, the distance, right? And then here rho and g are provided. R is 2, right? That would just be 4 pi. All these are constants, so I can move that outside. 4 pi rho g, and then just inside we have 8 minus h dh. So now, very simple integral. We have 8h minus 1/2 h squared. Of that is 1 to 4. 4 pi rho g. That would be 32 minus 1/2 times 16, so it'd be 8. And then minus 0 minus 0. So we have 4 pi rho h times 24, which is 96 pi rho g, which is option E here. Thank you for watching this video. the past exam archive and all the videos I did related to this exam will be linked in the description below. Please check them out if you're interested. Thank you.